Welcome back to Think Design Works Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and today we have a slightly different format. We'll try to explain very briefly in about 15 to 20 minutes a complex concept. And to help me with this, I have once again Adi. Welcome back, Adi.
Hello.
Cool. So no more introduction. We'll jump straight into the topic. We're trying something new today. And the topic is connascence. Connascence, as you can see here, is a software quality metric and the taxonomy for different types of coupling. Now, before I go into connascence, I have to say that this came as a prompt from a comment. Somebody, we mentioned connascence in one of our videos, and somebody actually asked in a comment, okay, but what is connascence? Because you kind of skip over it. And I thought, okay, that's a very good idea. Let's talk about it, because it is a very useful concept.
And not that easy to grasp, maybe.
Right. That's absolutely correct. It's quite difficult, but it's one of those concepts that I think once you grasp it, it makes a lot of sense, but it takes a while to get there.
Yes.
So how would you explain connascence in, I don't know, 2 minutes?
Yes, it's the degree of knowledge or degree of relationship. So if you could think that how you categorize maybe, let's say, family, friends, colleagues, and then people you meet at a party and you just don't have interaction that much, and then maybe someone you meet on the street a few times, and then someone you meet just once, I don't know, at the supermarket. Okay, so these are degrees of connascence in a way, because you have you are more in connection, you have more dependency, you have a better, an older relationship, you have more interaction. So that would be my, let's say, explanation of this connascence, but we wouldn't talk about people, we'd talk about software components.
Right. I think from my part, I have two different ways of explaining it. One is in terms of static relationships, things that know more or less about each other or that relate more or less to each other. And not only when we are talking about coupling, we are talking about things that are kind of in the same area most of the time. With connascence, it's more, it can be more distributed. So we can be talking about things that are distributed through code, but that tend to have a connection. The other way of explaining it is things that change together. And in this case, think about your whole code base and what are the things that would change together for different types of scenarios, right? So if somebody comes and says, let's introduce a new currency in the application, what changes in your application? Or we need to introduce a new formula or something like that. In that case, what will change? So connascence, from what I understand, is an extension of the coupling concept with some degrees of classifications, and we actually have here the degrees of classification. Would you say this is more or less what it's
Yes.
about? Yeah, okay.
Yes, for sure.
All right, so by the way, you are using the site connascence.io. I'm not sure who created this. Honestly, I haven't looked, but we'll post the links and you can check this out. So it's a metric like all metrics, is an imperfect measure. It takes a more holistic approach where each instance of connascence in a code base must be considered on 3 separate axes. Strength, so stronger connascences are harder to discover or harder to refactor. Degree, an entity that is connascent with thousands of other entities is likely to be a larger issue than one that is connascent with just a few. And locality, connascent elements that are close together in a code base are better than ones that are far apart. And it also gives a vocabulary for coupling. And I believe that the best way to explain it is to actually look at some of the examples, right?
Mm-hmm.
I think it's more, because this is very, very general. We have to look into examples. So let's see. First example, connascence of names. Right. And it sounds trivial, but it's actually quite important. Connascence of name is when multiple components must agree on the name of an entity. Method names are an example of this form. If the name of method changes, callers of that method must change. And this also points to another important thing. Connascence is an intrinsic property of any code base. You cannot have zero connascence in your code. You will have some connascence.
And it's natural to have it because it's maybe part of that natural complexity that we talk about.
Yeah. But understanding these relationships helps you understand how the code will evolve over longer periods of time.
Yes, exactly. So what we want to avoid is unnecessary connascence. So to avoid situations where things know of each other or things are coupled with each other without having to. Yeah. That is what generates issues. Issues of in many ways. Issues of changing the code, adding a feature, testing it, debugging it, many issues.
Yeah. So in this case, they give a very simple example. If you have a class request, a method self proxy, if you change the class name from request, anybody who calls request needs to change and call the new method, and so on. But I think what's even more interesting is another type of connascence based on names, which they don't talk about here, but when you have the same entity with different names, or you have something that is distributed around your code, they should be in one place, and that actually has a name, right?
A very good example is client-customer. Is client a customer? Is customer a client?
Right.
If you have one concept, but once you call it client, once you call it customer, then is the situation.
Yeah. And then the question is, when you change client, do you also change customer?
Yes, or you're just confused.
And maybe you have something that is, the customer entity that you save in your database, but then you have the client controller.
Exactly.
But the client controller is actually using the customer entity.
Mm-hmm.
And if you are moving into distributed application, it can become even more confusing, because maybe you have the client service and then you have a customer event.
Yeah. Yeah, and this cannot be enforced in any way than just thinking about it and having a dictionary of terms and using that term, that domain term everywhere.
Right. So this is what connascence is about, right? You have the name, and they say this is the weakest connascence because it's unavoidable, and I guess it's also because of the criteria that we were talking about before. It's not very strong. Okay, let's look at another one, type. Connascence of type is when multiple components must agree on the type of an entity. In a statically typed language, these issues are caught by the compiler. In dynamic languages, not so clear, right? Because you can do all these kinds of things. Here I also have other examples when you have, so this is a very simple one once again, but when we are talking about connascence of type, it can also be, one of the challenges is when you are using two different ways to represent the same type.
Mm-hmm.
And this is a very good example. Like maybe if in your code you are using this and this, so both, if people are listening, you can use number to represent a date, like 1/9/1984, or you could use a string or strings,
Exactly.
1 September 1984. If you are using both, it's a problem with connascence because you're using exactly the same concept underneath, and when you change that concept in one place, you'll need to change the other things as well.
Yes.
But I guess they treat this in connascence of meaning. Connascence of meaning is when multiple components must agree on the meaning of particular values. Right. And this, to me, another way to think about this is primitive obsession, right?
Yes. So because now here you have a concept, you have a meaning. Yes, you don't use primitives like integer strings.
Yeah.
So,
And an example is when a user role is encoded as integer. So get user role of a username will be, if user is admin, return 2. If user is manager, return 1, else return 0.
mm-hmm.
So in other places, I will need to look at if get user role of username is not 2, then permission denied. Which is, of course, a problem because these two can mean other things as well.
Mm-hmm.
Okay. Same with money, right? Very common problem. I don't think there's anything else to talk about here. Let's see some others which are interesting. Yeah, this is an interesting one. Connascence of execution. The order of execution of multiple components is important.
Yeah, we also call this time coupling.
Yeah. So a common example here, when you are sending an email, you create an email, you set the recipient, you set the sender. If you send it, you cannot set the subject afterwards because the email is already sent. So you need to set the subject before sending it. This is connascence of execution. Once again, it's something that exists. You cannot avoid it 100%.
Mm-hmm. But yeah, you can avoid on how you think the code and how you encapsulate things, that it's limited to just one place, and then you just reuse it. Like, instead of doing all this, you just encapsulate all these
In one
lines in one place with good order, and then you just reuse it everywhere.
Yeah.
Instead of having a connascence problem in tens, hundreds of places.
Yeah, so in this example, what they are saying in this example, the locality of the coupling is very low because everything is close together. But think about a scenario like this. Let's say a common example would be a multiple step transaction. Something that you create in one place, but then it needs to go through several steps, and it goes through several steps in a specific order, but in different components in your system. That is a connascence of execution, which is very difficult to debug and to understand. And when you need to change anything, it becomes really difficult to think about it. And that would be an example when locality is high, so things are not in the same place. All right. Let's see another one. So this would be execution. Let's see timing. Yeah, and the timing of execution of multiple components is important. So this means they don't have an example here, but typically it happens when you call different things. Let's say you call different APIs. And then it matters how fast they are answering.
Yeah, so if some gets timeout, then you need to do all sorts of all sorts of preparations or waiting and so on. So it becomes complicated.
Yeah, and if one of them is failing, then you need to do a revert transaction somehow.
Yeah.
And yeah, things become complex. And I think the last one that we have time for, let's see which one. Let's pick value because it has more details. Connascence of values is when several values must change together. This frequently occurs between production code and test code. For example, consider an article class which represents a blog article. When it is instantiated, it is given some text contents and its initial test state is draft. So then you test if you write a test, you test that the article state initially is draft. But then the problem is that this is a connascence between test and production code. So if you change the production code, you'll have to change the test. And the better way is to kind of encapsulate these states and have a clear progression, like which is the default initial state, and then you don't have to know if it's draft or something else in your test.
Yes, default values. I think this binds also with the approach with the object mother and where you have these types of initial states for objects.
And I think this is a very interesting case because we often see tests that are difficult to maintain because they are too coupled to the production code.
Yes.
This is only one symptom of one way you can do this to have this high coupling, but there are also other ways. Right? Okay. So, 2 minutes.
Yeah, I think these are the main concepts from Connascence. I think the other ones are maybe not that essential, and I think maybe you need practice, right, to see it, to understand it,
Yeah.
to use it.
Yeah, and I guess it's a good way to finish with some advice for people. And I'm thinking, the important thing is to start thinking in these terms and look at code and see and start seeing the connascence and try to figure out what are these three properties, right? Strength, degree, and locality for each connascence that you see. Just mentally do this exercise for a while, and then what happens is that suddenly you'll start seeing it everywhere. And you can't stop seeing it, actually. So it gets, you go on the other side. Anything else that you'd like to add?
I think conversations on these topics are important in the team with colleagues, and try to take these examples and maybe more. There are others on Wikipedia as well, and there are a few articles, and try to look at your code and understand how well it behaves from this point of view of connascence.
I will also add in the description some talks about this. I think Marco Consolaro was doing some talks on Connascence, if I'm not mistaken. Anyway, you'll see it in the details and in the refer videos. So if you want to learn some more, just, watch some of the talks on the topic. That is very helpful. All right, 20 minutes. Anything else you'd like to say?
No, it was it's a really nice topic. One of the important, maybe one of the few things I almost always use. So I think it's a really important topic.
All right. So, what do you think about our experiment? We tried to explain today in 20 minutes a complex concept. Connascence is quite complex. You need some practice to figure this out. Do you like this type of videos? Do you have any other complex concepts you like explained? Let us know in the comments. We love answering comments. We love seeing your comments. And as you can see, we even make videos starting from your comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart.